Transmission is essentially the lifeblood of the electrical system across the United States. A lot of the transmission infrastructure was built in the 50s, 60s, and 70s. So a lot of it's reaching the end of its useful life.
Yeah.
In Loudoun County, Virginia, there is an area. It's a data center alley is what they like to call it. Between now and 2028, they're estimating about 11.5 gigawatts of electricity to be consumed in that area for data centers alone. 11.5 gigawatts is about the same load that New York City would use, the entire New York City.
Yeah.
It's a huge amount.
All right, yes, greetings, welcome. We are here yet again at the Sounds of Solar podcast, your favorite podcast, I'm sure. Is it your favorite?
I know it. Of course it is.
Yeah, do you listen?
Is it your favorite?
Yeah. Do you listen to yourself?
Yes, of course.
the
Every
time.
week. I hear my voice in my sleep at this point.
Yes. Well, I hear my voice in my sleep for other reasons. But anyway, so we got a great show today. I'm Christoph Brun, your host, and joining me is...
Sheridan Henderson,
and
your other host.
Oh, sorry. And today we have Ryan Grady, Director of Transmission at EVS. Ryan,
Right.
Welcome.
Thank you. Thank you for having me today.
How does it feel to be on a podcast?
A little intimidating and
Okay.
nerve-wracking, but I'm ready.
Okay,
Let's
cool.
do it.
All right, sweet. Well, before we talk about transmission, we got to talk about something else. Sheridan, what do you want to talk about? I've been so busy the last month, I've got nothing interesting.
Where are you coming here from?
I'm coming here from Canton, Ohio.
Ohio.
Yes.
What's your favorite thing about Canton, Ohio?
I'd have to say it's my family is all
Yes.
close by.
Yes. And what's that other thing we were talking about?
The
That's
Pro
us.
Football
the-
Hall of Fame.
Yes.
The
Pro Football
famous
Hall of
one
Fame.
that we've all been to.
You know,
Yes.
Sheridan, I recall in your application for the EVS Sounds of Solar podcast host, you mentioned on there that the Pro Football Hall of Fame in Canton, Ohio was your favorite thing ever.
Yeah, my favorite trip I've ever taken was to Canton, Ohio. Out of all the trips, all the hiking trips, the mountains, the beaches, Canton, Ohio.
Yeah.
What's your favorite part about it?
Yeah.
The Pro Football Hall of Fame?
No, and my favorite part is outside of the Pro Football Hall of Fame, there are two transmission structures that are in the
yeah.
shape of field goal posts. How
No
about that?
way.
And they're painted the fluorescent yellow, too.
So Alex is going to cut that in the video, right?
Yeah, show a
He's
picture
got-
right here.
He's just vibing.
If you like football and you've never been there, it's definitely worth checking it out.
Yeah,
They got some pretty cool exhibits there.
cool. All right, well, next time I'm in Canton, I'm going to do that.
There we go.
All right, well, that's probably our segue to the actual point of this podcast, which, I mean, we could talk about the Pro Football Hall of Fame more.
We could.
I guess. You know, I have a lot of place kickers that are dear to my heart, but we won't do that. We're going to talk about transmission. And I think the first thing is, so what is it that you do, transmission? Can you explain this for everyone on the
Transmission.
record?
Well, I'll explain what it is first of
Yeah.
all, and then
Yeah.
what I do and what my team will be doing
Yeah.
too. But transmission is essentially the lifeblood of the electrical system across the United States. It's what transmits power long distances at high voltages to get to the customers that need it.
Mhm.
So basically, from a generation station, you have however it's being generated, whether it's solar or nuclear, goes to a substation. It gets stepped up to a higher voltage, anywhere from 138,000 volts all the way up to, in some cases, 765,000 volts. It goes long distances to other substations where it gets stepped down to a lower voltage, and then from there it can be distributed out to homes and businesses. So it's a pretty integral part of the entire overall electrical system to be able to get power moved from one area to another.
Mm-hmm. Do you think that transmission is the forgotten component in some ways? Is it overlooked in some way, shape, or form?
You know, I feel like if you asked me that question about 10 years ago, I would have said yes, it was overlooked. That's really when I started to have my eyes open as far as the investment opportunities that are out there on transmission. Where I came from previously, a lot of the focus was low-hanging fruit inside of the substation. So upgrading the transformers and the circuit breakers and the bus work and all of that it's inside of a substation. It's much easier to control. It's all inside of a fence. The harder work was what's outside of the fence, those transmission lines that go over multiple states, counties, they go over highway crossings, railroad crossings, rivers, you name it. We have to deal with all of those different terrain obstacles that are out there. From a permitting perspective, you have to deal with the easements and the rights to be able to do what you need to do for a transmission line. There's a lot more that goes into the overall project to be able to come up with a good deliverable and executable project. So from what I've seen in the past, yeah, it was a lot of low-hanging fruit, hit the substations, do a lot of our capital investments there, which are desperately needed too. And now I think the focus is on transmission for more reasons than one. That's one of them.
One of them probably
many
being
things.
capacity, I would assume, with just the ever-expanding energy market and the higher demand for it. You know, you build these originally, 50 years ago, more with a certain capacity to them, I would assume, and they may not have had the foresight to see just how much energy demand would increase in the next 50 to 100 years.
Yeah, absolutely. So you take a look at it, and you said the age there too. You're absolutely right. So a lot of the transmission infrastructure was built in the 50s, 60s, and 70s. So a lot of it's reaching the end of its useful life.
Yeah.
And
Is this like the majority of the grid, so to speak? Is this old?
A lot of it is.
Yeah.
Yeah, a lot of it is. And so you have aging infrastructure, you have electrification. I'm sure you or someone you know has electric vehicles, which maybe 20 years ago was pretty much unheard of.
I do have an EV. How
Good
did
for
you
you.
know that?
I didn't know that.
Who told you that?
So yesterday was the first day ever I've driven an electric vehicle.
Oh.
And it was amazing.
Was it Dennis's or
it
or
was
Andy's or
it was the Andy's.
one of them? Yeah. There's always one that's like, oh, you should drive this. Check this out.
Yeah. So I'm like all in now. I want to get one.
It's it's kind of dangerous, that point when you like haven't been in one or haven't driven one, and then you do, and it's like, okay, like I'm not gonna do this actually.
And you get it.
Yeah.
You get
I know.
the hype.
I know.
It's real. Yeah.
Yeah. But anyways, it's the electrification. The load growth is a big one too. Across the country, we keep hearing about all these data centers that are going in. That's another one that's driving the need for it. And then the renewables too. So we have a lot of generation, I'll say historic generation, that is going offline. A lot of the fossil plants are deactivating. A lot of the renewables, wind and solar, are starting to come online. But where the wind and solar is being produced is not where we typically have transmission to haul it over long distances to where it's needed. So all of those are reasons why there's so many opportunities to invest in transmission lines right now.
Gee dang, there's a lot of things going on. Okay.
Yeah, absolutely.
So one of the things that I think you alluded to here about we have a lot of demand coming in, and one of the things that's driving this is data centers. So can you speak to this behemoth that has changed in probably the last 5 years, and even maybe more recently in the last 2 to 3 years, and what this means for transmission and energy demand in general?
Yeah, and I'll give you a specific example of it too. In Loudoun County, Virginia, there is an area. It's a data center alley is what they like to call it, where they're projecting about.
Why is that? Why
Was it
are
just
they?
a
Because
blank space
there's
of
just-
land that was ready to be built on?
Yeah,
or-
it was an old factory that got torn down, and they had some of the infrastructure and land already there.
Yeah.
Probably land is very cheap to buy in that area. Another thing about that area of the country is that the majority of the internet traffic goes through that area outside of Washington, D.C.
Yeah.
So it was prime for that type of data center load growth. So they're building a lot of data centers there. And as a matter of fact, between now and 2028, they're estimating about 11.5 gigawatts of electricity to be consumed in that area for data centers alone. So just for reference, 11.5 gigawatts is about the same load that New York City would use, the entire New York City.
Yeah.
It's a huge amount. And then looking out further to 2030, they're saying an estimate of about 14 gigawatts. So the problem with the transmission side is that there's a huge demand there, and there's already a lot of demand with Baltimore and DC and those big metro areas there. The problem is that there's not enough capacity on the existing transmission lines to get all of the electrons and the electricity needed in that area. So there's a lot of proposals for very large multi-billion-dollar projects to try to get power in that area.
Yeah.
One of those projects is a 765 kV line. It's a 260 plus mile line that they're looking to build to the state of West Virginia to be able to support some of that data center load growth. So that's one example of what we're seeing, and that's one area of the country. And we're seeing this in other areas as well. Maybe not up to the 11.5 or 14 gigawatts of load. But still, all of those require very resilient, very reliable service as well. They can't see interruptions, and usually they have a lot of redundancy with the transmission lines that feed into those as well. So it's just driving the need for more of that investment on the T lines to make them more reliable.
Wow.
When you're looking at the industry, and what are the people that are kind of looking towards the future of transmission? Are they more focused on adding more capacity and more lines, or is there also a focus on improving the existing lines that are nearing the end of their design life? Like, what does the end of the design life look like, and then how to move forward from there?
Yeah, that's a great question. And it's a very challenging one too, because as we talked about, the infrastructure that's out there right now is aging. It's at the end of its useful life. A lot of it was designed with lesser design standards back in the day. So a lot of what we design across the country, in the most part, is the National Electric Safety Code, and those design standards have become more robust over the years. So what was designed back in the 50s and 60s is probably less resilient, less robust than what would be designed today.
Right.
And with the deterioration of a lot of those existing facilities, whether it's a wood pole or wood structure that's supporting these wires and insulators, those all degrade over time. So it's really a multi-pronged approach that you have to maintain the existing infrastructure that you have while you're also building new. And then that becomes the question of, well, what type of constraints do we have on outages to be able to retrofit or upgrade our existing infrastructure and still be able to get the electricity flowing to where it needs to go to? So that's a huge challenge that's out there right now.
Yeah, that's very interesting. Because that's something to think about with just, it's kind of two major problems that you're trying to solve at the same time while the energy demand just keeps going higher and higher.
It is, absolutely. And then, so a lot of times too, with what I would call the baseline projects where they're mandatory to support the load growth, it seems like some of the more supplemental projects, the condition-based projects to retrofit some of the older lines, those ones are the ones that kind of get left behind, unfortunately, because you can't rebuild it all at once. I mean, we could, but it's going to cost us a lot of money. We got to really think outside the box as far as what are the best way to construct these lines. I know in my past role, we were looking at a lot of constructability reviews, looking at energized construction. So literally rebuilding 345,000 volt lines while they're still energized.
Wow.
Those are the types of opportunities and really the thought process that needs to go on out there to be able to say, what can we do with the constraints that we have?
And also, who's willing to do it? Who's willing to rebuild those lines while they're still
That sounds
alive?
hardcore.
Yeah.
And there's so much planning that goes into it too, because now you have to take a look at the minimum approach distance, the safe working minimum approach distance that you can be from an energized line. It takes specialized equipment. So maybe instead of rebuilding a transmission line right down the right of way, in the center of the right of way, now maybe we're thinking about offsetting it by 50 or 60 feet so that we can build adjacent to the existing line. These are all of those really early on discussion items that need to be brought up when a team or a utility is thinking about how do we go about this problem, this dilemma of rebuilding all this infrastructure in a short amount of time.
So when the original designers of these transmission lines were looking at the design life and what is going to happen beyond that, what was their original thought process? I know that they didn't see the demand going up, but after the design life, what next after that? Did they plan for them to be improved, or did they plan for them to be rebuilt, or?
That's hard to say. I would say they probably had to have some type of plan to rebuild eventually based off of condition or based off of potential load. But I don't think they could have the designers back in the 50s, 60s, and 70s probably could have never predicted the amount of load growth that's happening across the country right now with everything that's going on.
Yeah. So one more question for me kind of on this subject. Did we have excess capacity in the transmission line network to meet what is happening? Because it seems like we've been building generation sources on our side for PV, but one of the most difficult things is interconnection. It's probably the most difficult thing is interconnection.
Yeah.
And while our supply chain works theoretically to just crank out these PV generating solar plants, you have to have the infrastructure to get the power to where it needs to go. But yet we have this data center problem that but it's already working, right? It's not like, hey, we could be using AI, but we're missing the energy. No, it works right now. So like, how is it working? And was that reserve capacity there already?
Some of it may have been there,
Mm-hmm.
and it's a matter of trying to get it from one point to another.
Yeah.
And I know there are some pretty large projects out there that are working on improving those interconnections. As a matter of fact, there's one. It's the Greenbelt Express. It's an 800-mile HVDC. I think it's at 600 kV
Yeah.
HVDC line, and those are the types of projects where they're trying to improve those interconnections
Mm-hmm.
to be able to get those generation sources to where the load needs to be.
Mm-hmm.
And there's other projects like that too going across the country right now to be able to support that as well.
That's crazy. Okay.
So there's quite a few ways that they can improve upon the transmission lines and upgrade them to handle. It seems like there's a few ways that they're able to kind of think about upgrading the capacity. Right?
Yeah,
Am I understanding that right?
Yeah, no, there's quite a few ways. So rebuilding all of the lines is not the only option that's out there. There's opportunities to change out the type of conductor.
Mm-hmm.
They have advanced core type of conductors where it can actually operate at a much higher temperature and it sags less. One of the main things that as transmission line engineers we're looking at is not only just the safety and stability of the structures, but also the sag of the conductor. And we have clearances that we need to maintain to facilities and primarily to the ground. With these newer advanced conductors, they're able to run at a higher temperature, which also means typically more ampacity, and they sag less. So that's one way to
Mm-hmm.
get more out of a transmission line. There's also something that is coming about too. It's a FERC Order 881 where they talk about dynamic line ratings. So dynamic line ratings is really where a utility would have to change the rating of their line. And ratings all come down to really the temperature aspect
Right.
more than anything else,
Mm-hmm.
and the ampacity that you can push through. But with the dynamic line ratings, that takes into account wind and a couple other factors as well, that depending on how much wind, the direction of the wind, they can actually push more current
Yeah.
through the line than what you normally would.
So this is variable based on
It's absolutely
instantaneous conditions,
right? Yes, it is. Yeah.
Mm-hmm.
So those are different ways where you can try to push more current through the existing lines that we have right now.
Okay. All right. So Ryan, we are at EVS, and at EVS we primarily build utilities. We engineer utility scale solar energy plants. Can you talk now about okay, we have transmission. You're here. Welcome.
Yes.
Thank you for coming here.
Welcome, Ryan.
I'm very happy to be here.
So maybe we touched on it a little bit earlier. Interconnection is obviously a huge problem in our industry. It's very difficult. But now we have transmission. We have this kind of integrated service. You have a team. Those two-part question. Talk about the team, and then let's talk about why this matters for our industry.
Yeah. So we have a couple of really well-experienced engineers, transmission line engineers. They have a background with PLS CAD, one of the softwares that they utilize to actually design our transmission infrastructure. And they've been primarily focusing on, like you said, those generation interconnects where
Mm-hmm.
you have the solar or even the battery energy storage, and you need to get it to essentially a substation, and then from that substation get it back out on the grid. Our piece is that transmission line piece to be able to tie into that generation. So that's what the team has been working on recently. Our intent is to expand our offerings as well with designing transmission lines on a much larger scale too.
Mm-hmm.
Can you expand more on what exactly the work that you're doing right now is at EVS?
Yeah. So the work that my team is working on right now, of course, we have the solar or the battery energy storage facilities, and from there, that needs to then go back out onto the grid in one way or another. And you have to have a transmission line that connects all of that back to the grid. So we're working on that piece of it.
Mm-hmm.
And in some cases, it may be very short. It may be just literally a span that drops from a substation to wherever it needs to go. In other cases, it could be several miles worth of transmission lines. And then we're looking to scale up this team and be able to take on more transmission line opportunities in the future as well.
So I'd assume that demand for that type of project work has gone up with the increase in solar over the past few years. That kind of specific niche.
Oh yeah, absolutely.
Yeah.
Yeah. Same thing with the substation. I know the substation team here at EVS has just grown massively just in the past like 2.5 years.
Yep.
And I would anticipate probably seeing the same thing with transmission line as well.
Yep. So the T-line that we are, I can call it T-line now, right?
Yes, you can call it T-line.
I'm cool now?
Yeah,
okay.
You're good. Yeah.
So these are still part of the private development, right?
Yes.
Like, because there's a gray area of like, that's the public utility, which is already kind of a quasi-private public situation, right?
Yes.
But like, we're going to build a private T-line that connects into the utilities T-line.
That's correct, yeah. So there's typically something called a POI, or point of interconnection.
Yep.
And that's what we would design up to.
Yep.
And a lot of these projects that we have here at EVS, that's where we stop currently.
Yep.
But no reason why in the future we couldn't go beyond that.
Okay.
And do some of that work for the utilities too.
So what does it look like coming, like, we engineer the power plant, we put it to the substation, the T-line's taking it to the next spot. What does that connection point look like? Like the T-line to the T-line?
It can vary.
Yeah.
That can be a point of interconnect at a substation, or it can be just a spot on a structure too, where
like you just plug it in at that one spot.
Yeah, essentially you have what's called a dead end structure, where you have your wire pretty much terminating on either side of the structure, and then a jumper loop that goes between the two. And
so it's like a 765 kV extension cord you're plugging in.
Yeah, it kind of is. Yeah, exactly. That's how you get those electrons from the solar field back out on the grid.
Okay, that makes sense. I get it. I'm a T-line guy now.
So obviously the existing transmission lines have been around for, as we talked about, 50 or so years. And this is kind of I would imagine the first major point of, we actually have to now redesign and improve all of these because of the energy demand. So how does that play into the growth of the workforce in the transmission industry?
Yeah, there's a huge demand right now for transmission line engineers, and it's a very, I'd say, a niche skill, and it's a challenge to try to find the folks that are needed for this, just on the scale of how many transmission line engineers are needed to be able to design solutions to tackle this multifaceted problem that we have right now in front of us.
Yeah, and it's an exciting challenge and problem to solve too. Like, that's kind of why I wanted to be in renewable energy. Like, what I design on a day-to-day basis is not like, it's not the Burj Khalifa, right? It's not like the most exotic structure you've ever seen, but it's about the purpose of what it serves, right?
Absolutely. Yeah. And you think about transmission and just the electric industry in general, it's the lifeblood of what we do. I mean, just think of how we'd be able to do our daily lives without it. It's everything that we need, and without it, it'd be a completely different world we live in. So you definitely need it.
And you can probably testify too, like, while it seems like, if you look at like transmission lines, and while the same way I look at solar piles, like, it doesn't really look that complicated, but once you get into the nitty gritty, it's like, oh, this is a serious engineering problem.
Yes. Yeah. I love that, because I felt the same way when I first got into transmission.
Like, it's just like, that's a pole.
Exactly. That's a 345 kV transmission line right there. And then to be able to have younger engineers come on to the team and start saying the same thing. It's like, I never noticed that there.
Yeah.
And now I see it all the time as I'm driving past it.
Yeah.
That's the name of the game, when you go into the field and you start noticing in the real life just all the connections to what you do on the daily.
Yeah.
What are some of the opportunities for the younger engineers and the students going into just really any engineering field that could have a place in the transmission industry?
Yeah, there's so many different opportunities. We have usually structural engineers for the PLS CAD modeling of our transmission lines, but that's just one aspect of it. Of course, a lot of our transmission lines are going to have foundations. And we have foundations that need to be designed, so we're utilizing geotechnical engineers as well, electrical engineers too, for the planning and studies of these transmission lines, to be able to say, we have contingencies in a certain area and we need to have additional load capabilities in these, or we need to have additional transmission lines for increased reliability. So mechanical, electrical, civil engineers, there's so many opportunities out there right now. And it's a super exciting time to be in this industry.
Yeah, just like anything in the built world, everyone's working on it. Like it's not just one group. Right?
Yeah. You can't boil it all by yourself.
So we've kind of covered the past, the here and now, and then what about the future? So what are you seeing like in the next few years? Like what is happening? Obviously crazy growth, but like are there any specific things you want to touch on?
Yeah, no, just the crazy growth that we have. I'm really interested to understand how we can utilize AI for a lot of what we do in the design aspect. There's just so many opportunities for any engineer out there right now. I think a big item that we're seeing now, it's not just upgrading to upgrade a support capacity, but it's also upgrading to have enhanced resiliency in the transmission lines as well, because we're faced with a lot of different climate changes right now.
Yeah.
Wildfires out west, hurricanes down south, whatever it may be. So there's opportunities to make the system more resilient.
Yeah.
And I think that's what is another opportunity that we have out there to really capitalize
right on. So just like on the PV side of things, like the choke point for us was interconnecting. Like that's we said that earlier, but on the transmission side of things, like to meet the growth demand, what are some of the major pain points there, do you think?
Yeah, major pain points that we have, a lot of it comes down to the design, the right-of-way needed, especially for new lines.
Yeah.
If we're building
so permitting and like essentially
permitting, environmental, all of those aspects go into it. And then just the approval too for these large projects through other regulatory bodies that are out there as well.
Do we have issues like material shortages and scarcity and things like that, or not so much?
Yeah, that exists still. It's I would say the supply chain issues are getting better ever since we've been moving away from COVID, but those still exist just because everyone across the country seems to be doing these types of upgrades. So the lead times on material that used to not have long lead times, we're seeing it now.
Interesting. Okay.
But if there's one thing that drives just getting it done and getting these things built and designed and executed, it's just the demand for it.
The demand, like you're saying, the demand won't go away anytime soon. And my kind of joke is, unless someone develops a way or technology to cool data centers more efficiently. But I still think it's going to be there because of electrification, the need for it from an aging perspective as well. There's going to be a need for that investment for the long term.
Like other industries aren't slowing down. And the industries are needing this energy demand.
And every industry is like incorporating some sort of AI into their workflow, like every single industry. I mean, it's relentless, right?
Absolutely.
Yeah.
Yep.
All right. So Ryan, thank you again for being on the Sounds of Solar podcast. This is your first podcast?
This is my first one.
Really?
Yeah.
You weren't on the Pro Football Hall of Fame podcast?
No, I wasn't.
Dang
no.
it.
I listened to that one too.
You listened to that one, of course you do.
So
our softball question we usually ask people here is if you had to give some advice, probably to a new transmission line engineer or someone like that.
Yeah.
What would you tell that person?
Boy, even just myself looking back 19 years ago when I first started this, I'd probably say make an attempt to know the big picture, to understand the big picture and how you fit in. And then also seek feedback on what you're doing. And I'll expand on those. So knowing the big picture, I think for me is what has helped make me successful. I've been in a variety of different engineering roles, whether it was transmission line design, distribution design, overhead and underground, and then moved into project management. But I think to understand the climate of the entire industry and the challenges that exist out there really helped me understand where those opportunities lie for investment and for growth. So that's a big one. And then the seeking feedback is a big one for me too. As a young engineer, I was always taught, when you design something, take it over to that crew that's going to be building it and get their input on it.
Yeah.
Make sure that this is something that can be constructed. It can be something that can be maintained for the future. So I would say to any young engineers out there, try to seek that feedback as much as you can. Get that experience out in the field to ask the folks that are constructing it or maintaining it, is there anything that could have been improved on this?
Yeah.
And I think that helps establish that feedback loop of always continuing to improve those designs.
Yeah. wise words. Those are my things too. Like the big picture and like, can we actually build this? Like that's,
you got it.
There you go. All right. From all of us here at EVS, thanks for watching. Do the thing. What is the thing, Sheridan?
Like, subscribe, comment, share with your family, your friends, your dog, your cat, anybody in your life, any living being, share it.
Living entity. A plant is a living being. Remember?
It is.
We talked about this.
Share it with my plant
Yeah.
right after I water it.
Well, we just watered the plant in here, so I think it'll live until another episode filming date. Anyway, thank you so much for watching, and we'll see you later.